Welcome everybody. In this video, I want to discuss domain and range. So I have a couple of definitions written out already. The first is for relation. So any set of ordered pairs is called a relation. Relation just means relationship. So there's some sort of relationship between two variables, right? Usually we say X and Y data, but whatever two variables there are, if there's a relationship that exists between them, so we're creating paired data, we're creating points, maybe we're creating an equation or a graph, that is going to be a relation. So we typically think of it as paired data, but it also includes equations and graphs because those are also made of points as well. Now, when we're talking about relations, we define the X coordinates as the domain or whatever your first variable is, and then the Y coordinates or whatever your second variable is as the range. So all your X values are considered the domain and all your Y values are considered the range. So what I have written out here is a first example where this is a relation and it's just the most basic kind of relation. It's just a finite set of points. And you could also do something similar with a table as well. So a table is another way to write a set of points. And if you want to find the domain and the range, we do the following. So for your domain, you're just listing out your X values or whatever your first coordinates are. So for instance, in my sets of points, I have a 0, 3, a -1, and a 3. So when I have a finite set of points, what I would do is I would use a little squiggle, which shows set notation, and then I would list them out. So for instance, 0, 3, -1. Now I don't need to list repeats though. So even though I have another 3 here, I don't need to list it again. And I'm done. You don't have to list it in order, although you will often see, particularly in textbooks and things, sets listed in order, but they don't technically have to be in order, just if you're running individual points. For the range, this is the set of all Y values, or whatever your second variable happens to be if you're not using X and Y. So if I look at my points, I can see there's a 2 there, a 3, a 0, and a -2. So I would write it as a squiggly line for a set. I have a 2, I have a 3, a 0, and a -2. Now I do have to write all 4 of these. 2 and -2 are different. Because the 3 appears in domain does not affect the range at all, so you still have to write them individually. It's only if they repeat within the same set. Or again, if you prefer this in numerical order, least to greatest, you could also write it like this. But again, if you're just writing a specific number of points here, then you don't really need to have them in order. We just don't write repeats. So if you have a set of points, or again, if you have a table of values, it's the same idea. The X values or your first coordinates are your domain, and your second values are your range. Now that's the easiest form. It can get a bit more complicated if you have an equation or if you have a graph. So let me start with an equation first. Now I'm actually just going to do the domain here. The range of equations is a bit trickier to figure out. It's sometimes easier just to graph it and actually see how to do it that way. And I'll show you graphs in a second. So for equations, if you're kind of getting stuck on equations, the best thing to do is just graph them, and then we can look at it more visually. And again, we'll do that in just a minute. For equations, though, there is a big thing you do have to watch out for. And there's actually multiple things, but the biggest one that we're going to encounter right now is making sure we don't divide by 0. Right, so no dividing by 0. We know that. So if I look at my first example here, I have the equation y = 1 over x. So if my denominator was 0 there, then that would be bad. So what happens here is I have to make sure that my denominator is not equal to 0. So my denominator here is x, which means that x cannot be 0 here. So for my domain, it's going to be all values except for 0. So we could either write something like this. So all values of x such that x is not equal to 0 using set notation here. Sometimes we'll just use a colon in between as well. Or if you want to do it in interval notation, we can write it like this: -infinity to 0, union 0 to infinity. So remember, by using parentheses on that 0, we're skipping over it. So we're including all values there. But instead, again, we're, excuse me, not allowing. the next example, I have a regular linear equation. I don't see anything in a denominator. Technically, there's always ones, but I mean, I'm looking for variables and denominators. I don't see anything here, so there's nothing to worry about. At least at this point. Again, there are a lot. There are not a lot, but there are other restrictions we'll watch out for later. But for right now, dividing by zero is the big one. So there are no restrictions here. I don't see any issues. So my domain in this case is all real numbers, or an interval notation, negative infinity to infinity. Let me just throw in one more that actually does have a denominator just so you can see it. What if I have something like y is equal to 4 over x plus 2? Right, so again, I have a denominator there. So I do need to make sure that x plus 2 is not equal to 0. So you may have to do a little bit of solving here. So x cannot be negative 2. So you just want to be careful. It doesn't mean that the value there is always 0, right? It just depends on what the denominator looks like. So in this case, negative 2 would be the issue, because if I plug in negative 2, then negative 2 plus 2 is 0, right? If I plug in 0 here, it's actually fine because 0 plus 2 is 2. So you have to be a little bit more careful with those denominators and just make sure that you're figuring out, okay, well, which value would be bad here, right? Which is not going to work. And we're going to take that out of the domain. So domain is everything that works, all the good stuff. And then we're going to make sure we exclude anything else. Now, the last thing I want to talk about are graphs. So I have a few examples already graphed here if you, again, want to pause the video. And we'll do domain and range this time. So we can definitely see the range in the graph. So if you have an equation and you're not familiar with the equation, I really recommend just graphing it. There's a lot of graphing utilities out there too that you can use technology-wise to help you graph quickly as well. So we're still going to do domain and range. And again, I really want you to be careful here and think about your directions. So remember, when you do domain, I'm just going to abbreviate it as D, you're looking at the x values, right? So on a graph, your x-axis is the one that runs horizontally. So you're looking at values in a left to right direction. When you do the range, you're looking at the y values, right? So your y-axis runs up and down, so you want to be thinking in a up and down direction. And it's really hard to do, but you want to just think one direction at a time. So let's do example A first. I'm going to start with my domain. Okay, so my domain are just the x values. So just think about what's happening left to right, and you're going to follow that graph. So if I follow my graph towards the left side, I see that it does keep going to the left forever, right? Again, I know it's going down, but ignore that direction. Just think left, right? This is going to keep going left forever. And if I follow it on the right side, I do see it keeps going to the right forever, right? There's no holes, there's no breaks, it doesn't stop. So it's going to include all x values. So my domain there is negative infinity to infinity. Now, before I come back and do range, let me do the domain here and show you something that's not negative infinity to infinity. So here, when I follow my graph, right, I do get stopped, right? There is a closed circle here, so we're stopping here. And on the other side, we're stopping here. So it does not go continuously forever in both directions. Again, domain, you're just thinking about the x's. So as I move towards the left, the last x value it hits is negative 4. And as I move towards the right, the last x value it hits is 2. So here's an example where we're going from negative 4 to 2. Now, those are closed circles, so those endpoints are included. So I would use a bracket. Remember, if they're open circles, we would use a parenthesis because they're not included. Another way you could write this too is that your x values are between and including the endpoints negative 4 and negative 2. All right, let's go back to A for a second, and we'll do A and B together and do the range. So for your range, again, you're just thinking about up and down. So don't think left to right anymore. It's just y values, just up and down. So if I follow this graph, I see that it would keep going down forever. If I go the other direction, it keeps going up forever. So this first example has both domain and range of negative infinity to infinity. It's going to go through all values at some point. In the case in B, though, it's not the same. If I follow the graph, it does stop here. So the lowest it goes is 0. And the highest y value it goes to is 5. And again, there's no holes or breaks or anything in the middle of it. So we're going from 0 to 5 in this case. Again, because these are closed circles, I am including the endpoints, so I'm using brackets there rather than parentheses. All right. Now the last two, again, just two more shapes, just kind of mixing it up here. And on the left, let's start with domain. So again, we're thinking about just left to right. That's it, left to right only. So if I follow this graph to the left side, it does keep going left forever. If I loop back around and follow it to the right side, it does keep going right forever. It's going to keep going off as that U. So my domain here is negative infinity to infinity. However, for this one, I have sort of an oval shape. If I follow my oval around, the furthest left I go for the x value is -3, and the furthest right I go is 1, right? Everything is always in between those two values. And again, this is a oval shape. Everything is included, right? There's no holes in it. So we're going from -3 to 1 with brackets there because we're including those endpoints. For the range, now if I look at my graph here, the lowest point I go to is here, right? I can't go below this point. If I try to follow my graph lower, it just doesn't go lower. So for the y value, the lowest you're going to get is -2. There's nothing down here. If I follow that graph upward, I can see that this does keep going up forever though. So for my range, my lowest value is -2, and I'm going to infinity. I am using brackets there. Again, there's no hole here. It's just a nice continuous curve, so that -2 is included. And then over here, again, if I follow that oval, the highest value I get to is right here at 1 on the y-axis, and the lowest value I get to is right here at -1 on the y-axis. So all of my values are between -1 and 1. As a little side note too, just coming back up to here, I did show you a different way to write this one. You could write this one like this as well. So it's the same sort of idea, but just keep in mind you're using y values there instead. We typically tend to use interval notation for a lot of this, but again, if you were using set notation instead, then we could write it that way as well. So you have 3 different ways that you could look at relations that we've seen so far. Sets of points, also a table, equations, and graphs. So sets of points is the easiest one. You can just pick out the x and the y values for domain and range. For equations, for right now, the biggest thing we're watching out for is division by 0. But as I said, there are other things we will watch out for, and in mathematics that we watch out for. So that's not the only one, but it's one of the most common ones that we see. And then for graphs, and I even like graphs for equations too. So if you're really getting stuck on an equation, then just graph it. And that's really going to help you as we focus on domain and range one direction at a time. So domain are your x values. So you're just looking at the left to right direction, moving horizontally. Range are just your y values. So you're looking at the vertical direction, down and up. And again, it's really hard to not do them both at the same time. You really want to just practice doing one direction at a time. If you're having trouble too, it doesn't hurt to use pens to just follow along the shape, or to even move left to right and see what happens. Well, when I move left here, the furthest value I see is at -3. When I move right, the furthest value I see is at 1. So using some sort of visual to help guide your eyes can be really helpful there too.